2021 GCE ADMA paper 2 question 1. Actually, this is question 11. The following diagram shows a cylindrical metal plate of radius x centimeters and height h centimeters. Given that its volume is 500 cubic centimeters, express h in terms of x. So to do that, you can just take advantage of this fact here. So given that its volume, we know that the volume of a cylinder is given by the base area times height. So since the base is a circle, the base area will be given by pi r squared, and then our r is x, so that means we have pi x squared multiplied by our h, which is h. So now we want to express h in terms of x. So we don't want this v, and fortunately for us, v is equal to this. This thing has been provided, so you can say 500 is equal to pi x squared h. Has pi been given? No, so we can just leave it as pi. So now we simply make h the subject of the formula and we are done. So this, and then writing h this side, we have 500 over pi x squared. So that means you have expressed h in terms of x. As you can see, we only have an x. This one is equally a constant. And then hence show that the total surface area of the cylinder is given by a is equal to 2 pi x squared plus 1000 over x. So to do this, we're talking about the total surface area, normally denoted as A in additional mathematics. So the total surface area of this closed cylinder, let me just check again, is the diagram shows a cylindrical metal plate of radius. Yeah, it's closed because this is a metallic thing. It's not like an actual cylinder. It's just solid. We don't have any space inside, so it's definitely closed. So our A is given by 2 pi r and then h plus r. This is the formula. You can remember this from grade 8. So A is equal to 2 pi. Our radius is x. Then our h is this, so we can say 500 over pi x squared, and then plus our r is x again, so we can expand and write it in that form. So this times this, of course this is 2x pi, so 2x pi multiplied by 500 over pi x squared, then plus 2x pi multiplied by x. This will simply be 2x squared pi. So x squared, because we have an x here and an x there, no denominator this side. So now pi and pi will go, one of these with one of those will equally go, so we remain with this times this. This will give us a 1000, then over x, and then this is 2x squared pi. So now you can write this in that form. So you can start with this. Of course they started with 2 pi, so let's do it the same way. So 2 pi x squared and then plus 1000 over x, and you have shown. So you can even include the units like they did. And then on part B, Part B is saying given that x varies, find the stationary value of A and show that this value is minimum. So to show that this value is minimum, we have to find the 2V, actually the 2A, the x2, and show them that this number is greater than 0. Of course, at x is equal to k. So now let's find the value of x. To find the value of x, we have this formula here, and we are told that it varies, so we can differentiate this with respect to x. So dA dx will simply be, when you differentiate this, you have 4 pi x, and then this one here is the same as 1000 x to the power negative 1. So when you differentiate it, it will be negative 1000 x, and then this one, negative 1 minus 1, you have negative 2, like this. So since this is like the stationary point, at the stationary point, dA dx is always equal to 0. So we can substitute this with a 0, because we know that at that point dA dx is always equal to 0. So we have 4 pi x minus 1000 x squared. And then you can take this one to the other side, so that we have 1000 x this, and this will be equal to, maybe we can write this as, okay, maybe later, like this. And then we can write this as a fraction, so that we have 1000 over x squared, which is equal to 4 pi x, and then let's cross multiply. When you cross multiply, you have 1000 4 pi x to the power 3. Then let's divide both sides by 4 pi. So 4 into this will be 2. 4 into that is 2. 4 into that is 5. So that's like 250, which over pi, which is equal to x cubed. So now to find the value of x, you can simply find the cube root of that number, like this. So you can leave it like this, or you can get an estimated value from your calculator, and then hence show that this is a minimum. Show that this is a minimum. So we can differentiate this again to find the 2a dx2, and verify that this number will be will be greater than 0. So when I differentiate this, the 2a dx2, this will simply be 4 pi, then minus this one will be plus 1000 x to the power negative 3, like this. So now we can find the 2a dx2 when x is equal to this. Of course, this is not the square root, it's supposed to be the cube root. And I'm glad I didn't use my calculator because of that. So the 2a dx2 when x is equal to the cube root of 250 over pi will be 4 pi plus 1000. Okay, I have run out of space. Let me just write it here. So the 2a dx2 at the point where x is equal to the cube root of 250 over pi will be 4 pi plus, of course this is Okay, 1000. And then we know that this thing here can be written here as x cubed. So instead of writing x cubed, we know that x is equal to this. So we can say the cube root of 250 over pi cubed. Remember, it is cubed here, and I've decided to write it as a denominator. So this and this will cancel out. Before we go any further, you can even see that this is a positive number, because there is no way you can get any negative from here. So this is like 1000 divided by 250 over pi, and then this would be 4 pi plus 1000 multiplied by pi over 250. So this into this is 40, is it 4? Yeah, 4. This will be a 4. So we have 4 pi plus 4 pi, which will give us 8 pi. And since this is greater than 0, you have shown, hence shown. So you can say since d2a dx2 is greater than 0, what are we talking about? Show that this value is maximum. So we can say x is maximum, and you are done. Actually, a is maximum.